So let's begin our project today. Today we'll be seeing a classification project. So in a folder I have saved this data frame. Data set is saved. I'll open the Jupyter notebook now. I will navigate to the folder, that is desktop. On desktop I have saved it. ML income classification, that's there. And train.csv. This is the data that I'll be using. Opening a Python file, Python notebook. Okay, here it is. Income classification. So this is an income classification problem where we have to predict whether the income is in the data set. Actually we are given, means the target variable is that we have to predict the income whether it is less than 50k or greater than 50k. So here is the heading. Okay, rename. Achha, it's not allowing me to use the special characters. Oh, no problems. I'll just remove it. Okay, it's done. It's a very good idea to write a heading of the heading of the notebook. Means what your program you are doing, we should always write the heading, because the next time when we are using this notebook, it will be easier for us, because as we go on we are making a lot of projects, so it gets quite confusing. So here we have to use the data set, means you have to use the data set and train a classifier. It is a classification problem. So we have to train a classification model, and we have to predict whether the income of the person is less than 50k or greater than 50k. K means 1000, 50,000. Okay. So first of all, we will import the libraries. We will be importing NumPy, Pandas, Matplotlib, and further libraries we will be importing as we require them. Import Pandas as PD, import NumPy as NP, and import Matplotlib as PLT. Sorry, matplotlib.pyplot as PLT. Okay. Now we will use the pandas to read the data frame. Means we will use to read the data and save it in form of a data frame. So df equal to pd.read.csv train.csv. It's done. Df.head will display the top five entries of our data frame. So here it is: age, work, class. These are the features that we are having, the columns. And the income, this income underscore greater than 50k, this is our target variable. So basically whether we have to predict whether the income is greater than 50k or less than 50k. I'll hide this operation. Okay. So df.shape, it will give us an idea. So we have idea of number of columns and number of rows. So we have 43957 rows and 15 features. This 15 features is including the target feature, that is income income greater than 50k. So there are 43957 instances and 15 features, out of which one is the target feature. Okay. Okay. So now we'll be moving on to feature engineering part. So in feature engineering, what we have to do, we have to perform some of the operations. Basically, we have to check our features and see whether we can enhance it so that it can be better used for our model. So feature engineering steps. First is finding the missing values. We have to check whether there are any missing values in our data frame, in our data. And if there are some missing values, we have to deal with it. Next thing is outliers. Then we have dummy variables, that is to deal with the categorical variables. Correlation, There seems to be okay. Okay, so let's move forward. First, we'll be dealing with the missing values, means checking for the missing values. So df dot is null is na. We can use is na. We can use is null also. So df dot is na dot sum. This is showing us that there are three features that are having null values, and these are significantly large amount of null values. 2000, they are in the range of 2500, and one is 763, that is native country. So for the missing values in categorical type, work class, I have seen the data frame, and by looking at that I know that work class, occupation and native country. If we check the data frame, we see I see that these are the categorical values. So to fill the missing values in categorical features, we use mode. That is the most frequently occurring element. Had it been a numerical feature, then I would have filled it with the metric of means median. I would have filled with median, central tendency. Median is having central tendency, or I could have used mean also, mean or median. That is depending upon the data that we are having. See, if I check it, work class is a categorical type, right? Work class, occupation, and the next thing is native country. So I'll be using the mode, that is most frequently element, to fill the missing values. df dot work class equals to, sorry, yeah, df dot work class dot fill na df of work class dot mode. So for the work class feature, mode will be calculated and it will be filled in the missing places. In place equals to true means make the changes, and that it is saying that you have to make the changes on that data frame itself. Now I'll be using, okay, same for occupation and same is for native country also. I'll be using copy paste for it. Okay, it's done. Now let's check it whether it worked or not. df dot is na dot sum. Okay, so there are no null values. So we have dealt with the missing values. All the null values are replaced. Okay. Now, second, we'll be looking for outliers. Okay, we'll be looking for outliers in the next step. Here what we are doing, we are checking for redundant features. So first let's just display two of the columns of the data frame. See, here education and educational underscore num, these are kind of giving the same information. These are giving same means similar information into different in different format. Education, it will be 11, 12, doctorate, PhD, depending upon that. And educational underscore num, that has assigned a means equally weighted values to this educational. So educational underscore num can be used. We will drop the education column. We could have here we are choosing to keep the educational underscore num because generally our model prefers numerical values. This categorical values are not preferred by our model for calculation. So that's the reason. df dot drop, we will drop the education. I'll copy paste it. I'll have to define its axis. Axis equal to ones means columns. That I have to drop, I have to search for this feature, means this variable along the column and drop it. In placed, okay, in place equals to true. And in place equals to true means that you have to make the changes on this data frame itself. This data frame means df itself. So now we see that df dot shape, the number of features has reduced to 14. Moving on, checking for the outliers. So for checking the outliers, generally we check the outliers for the numerical category, numerical values, numerical features, numerical type features. So all the numerical features are to be checked for outliers, and we have to find some way to deal with them. In this problem, to just for demonstration and for the simplicity of this demonstration, we will just be checking the outliers in age category, and we will find some way, some simple way to deal with those outliers. So first of all, we can have a visual representation of it by using the box plot. To use the box plot, I'll have to import a library cborn. So import cborn as SNS. Now I'll use sns.boxplot data and age. Data will be my data frame df. sns.boxplot. Data is equals to df. X equals to age. So now you see these the dotted lines, dotted points that we see outside the range. Those are the outliers. Now how to know what exactly are those outliers? So for the outliers, the concept is that we have to 25 percentile and 75 percentile. So the range is decided by interquartile range. We'll get to know as we further move in this program. So I'm defining a function that will find the outliers for me for any columns. So define return underscore outliers df. Df will be the column that will be passed into this function. Q1 is that first 25 percentile of the values. So df dot quantile 0.25. Second will be Q3, that will be 75%. df dot quantile 0.75. Okay. Now IQR, that is interquartile range, it is defined as Q75 minus Q25. That is Q3 minus Q1. Q3 is my 75 percentile and Q2 is my Q1 is my 25 percentile. So the lower limit for my outliers can be lower limit ones and upper ones also. So for the lower limit, they are Q1 minus 1.5 into IQR, and upper is Q3 plus 1.5 into IQR. This is a concept. This is how it is defined. This is how we find the outliers. Now I will make a outlier array list, and I'll save in that. For I in df, if I is less than lower, or if I is greater than upper, then we have to save that value in the outlier list. Outliers dot append I. And finally, this outliers will be returned. Invalid syntax. Okay. Okay, I have made some small mistakes. All right. Return outliers and df of each. df of each. Q3 is not defined. Okay, I have made a mistake here. That was supposed to be Q3. I had written it Q2 by mistake. No issues. Let's execute it again. Okay. Lower and upper also some mistakes are there. Upper is not defined. Why is upper not upper? Okay. I made a silly mistake. Okay, here it is. So I have got the list of outliers here. I'll save it in an outlier list. Now length of OLR. So there are 193 outliers in the age column. The maximum value is 90 and the minimum value is 79. So basically the people from the age of 79 to 90 are counted as outliers. Means those values are kind of way above the range. So we see that the feature age has 193 outliers. See, generally in the job, the people are having the age in the range of 18 to 65. In our case, the age of 79 to 90, generally we don't see. Generally, we don't tend to see people of this age working. So from 75 to 90, the people who are having this age, we will remove it. We will simply drop these because there are only 193 values are there, so it will not affect our data set. We will not be losing much information. So for working class people, generally the age is between 18 to 25, 18 to 65. Okay, so in this program, we will remove the upper limit outliers. This notebook and dataset, you can access it. I'll give you the links for downloading them if you wish to access them. So df.drop.age where age is greater than 79. Just a minute. Age greater than 79. So the first one will return me the values where age is greater than 79, and the second one will drop those values. It will those index okay. In place equals to true. Now let's check it. df.shape 43791 and 14 columns. Okay, next we will check for correlation. For correlation, we'll be using the correlation matrix. Let's see how it is done. df.core. Here is the correlation matrix. For a better visual representation, we can plot the heat map. I'll use sns.heatmap. sns.heatmap df.correlation. Annotations I want to be visible on the heat map, so annotation equals to true. And CMap. CMap is the color scheme that will be used. I will use oranges. Seems to be some error. Okay, got it. Just to make sure that the figure is, I want to increase the size of this figure. So I will just plt dot figure fix size 10 comma 10. Okay, it's done. Plt dot show. It hardly makes any difference, but it's okay. So here the last column is income greater than 50k. Income greater than 50k. So its correlation with the other features we can see here. Income with income will the correlation will be shown as 1. So in this we see that the FNL WGT, which is the final weight, this is having the lowest value. It is a negative value and that is very less. It is less than 1 and 0.00. So this is not really contributing to much information, not really giving much information in this. It is not much correlated with my target variable. So I will drop this feature. Dropping the final weight column. Df dot drop. What's the final weight? Okay, I'll copy it. See, copy pasting the feature names, it usually saves time and it ensures that some spelling mistakes are not there. X is equal to 1, we have to define to tell it that it's a column. Int is equal to 2, make the changes on the same data frame. Let's check it now. So my final weight is gone. Now we observe that we are only having 13 features. Okay, let's move ahead. Next, see, our model generally it prefers numerical values. So for the categorical values, we have to do something about them. So we do the encoding of these categorical values, and the encoding it is of two types. One option we can use the label encoder. Other option is to use one hot encoding, which is called OHE. So label encoder is used where we have ordinal data, means the categorical values that we are having, they are in some sort of order, and weightage. Means order and weightage means that means some when we translate it into the numbers, there will be a sequence to it. We'll understand that later. For the ordinal, that is ordinal type of values, where the means we are not having any set order for it. There we use one hot encoding. In this case, we'll be using one hot encoding. For that, we will be using dot get dummies of Python. So first of all, let's get the list of categorical values that we are having. This is a very handy piece of code that I'm using here. Categorical values equals to list df dot select underscore d types include equals to object dot columns. So basically all the object types or all the types of the features that are of object types, which is the categorical values, that will be saved in this variable. When we are having a data frame that is having a lot which has a lot of features, we will be getting such data frames also. So this code is better to get the things instead of getting it manually. We can deal with the manual things when we have 15 to 20 features, but after that it becomes a tedious job. So it is better to automate it. So df equals to pd dot get dummies, data equals to df, and we have to get dummies for what? The categorical values, which is saved in categorical underscore values variable. I'll just copy paste it here. Okay. Now let's check the shape. 66. Here one more thing we can do. We can drop the first variable of the dummies. So for that we use df underscore first drop underscore first equals to true. Okay, there is some problem here. Let me check it. Mm, drop underscore first. For some reason it's not working. Let me check it. Drop underscore first is true. Okay, I have understood the problem. See, I had already executed that program, that line of code. So when I had executed it, it had already. Okay, so it had already made the changes on that data frame. So that's why now I have what I did. I restarted the kernel from the scratch. The whole code was executed again from the first line of code. That way, a new data frame was imported at the first step. So any changes that was done previously that got reversed. So the error I was facing was because of the data frame had changed when I had executed the line earlier. So that's why when I had made the modification, it was not accepting it. Okay. Just for presentation sake, I'll change the numbers. Actually, presentation does matter when you're submitting a project. Or it is good for referring it the next time. Fourth and fifth. Okay. All right. Now it's trying to train to split our data. The data frame that we are having, it is having many features. Many features and many columns also, rows also. So these rows, this data frame will divide it in two data frames. One I'll be using to train the model and the other one I'll be using to test the model. So first of all, I have to define my x and y. So x will be having all the features other than my target variable, that is income greater than 50k. So df dot drop, I will drop this x is equals to 1. Here I don't have to use the in place equals to true because those changes will be saved in the x data frame. Invalid syntax. Okay, I have to use the string format. Okay, and y will be having only the target variable, that is income greater than 50k. Again, a simple copy paste. Need to do some modifications here. Okay, let's check x and y. So I have x and I have got y. I'll remove this because they are of no use to me. Just for seeing, but just for checking the data frames, I had executed these two lines. Now, I will import train test split from model selection. So from sklearn.model underscore selection, import train test split. Now x underscore train, x underscore test, y underscore train, and y underscore test is equals to train test split. I'll put pass x, y, test size. I will define the test size. I want 20, I want means 25% of the data to be used for testing and rest 75% I want to be used for training. random state will freeze those random values. It will be selecting those random values and it will freeze it at that point. Only those set of random values will be selected. For that we can put any constant number for random underscore state. Okay, it's done. Next. Now I will be standardizing the my data frame. Standardization is a good step. It generally it helps us to train the model better. It brings the data into same scale. So from sklearn.preprocessing, import standard scalar, make the object of standard scalar, that is sc equal to standard scalar. Now x underscore train equal to scalar dot fit underscore transform, and pass the x underscore train. Okay. Y. No, sorry, not scalar. It will be sc. The object I have created is sc. So sc dot transform x underscore test. Okay. I seem to have made a mistake here. Transform. Okay, transform. Sorry, spelling mistake. Okay. I want to check the type of the variable. So now it has become an array. X underscore train is of array type. Okay, now we'll be training different models. So this is a very excellent program. Means you will get to look at the implementation of various different models for classification, algorithms and models for classification, and we will also be evaluating their metrics. So you will have an idea of how each one of them are performing and which is the best one to use, and what are the cost and benefit of those algorithms and models. So we'll be using KNN classifier. We'll be using random forest. We shall be using decision trees. We will also demonstrate logistic regression. And XGBoost. Further, we will also be doing hyperparameter tuning for all these models. Hyperparameter tuning is done to basically select the best parameters for these models, so, so that our accuracy or whatever metric we are using for checking our model, that is the best. So we'll search for the best parameters for the above algorithms using randomized search CV. So let's begin with the KNN classifier. So from sklearn.neighbors, import kneighbor classifier, kneighbor classifier. Now make an object KNN underscore CLF equals to kneighbor classifier. Now it's time to define the hyperparameters. The parameters that this kneighbor classifier uses. So one of the parameters are n underscore neighbors. So I want to check it from 1 to 20. N underscore neighbors, I want to check from 1 to 20. Metric is equals to Minkowski. P value is 1 and 2, which is the power parameter. Algorithm is auto. And weights equals to uniform and distance. Leaf size equals to list range 1 to 20. Now I'll put all these hyperparameters into a form of dictionary. That dictionary I'll pass into randomized search CV as a parameter along with the object classifier. KNN underscore hyperparameters is equals to dictionary. N underscore neighbors equals to n underscore neighbors. Next will be metric. Okay, so I have put this into a dictionary in the form of dictionary. Now I'll make an object for the randomized search CV. So KNN underscore grid search equals to randomized search CV. Here estimator I will use the KNN underscore classifier CLF, that is the object that I have made for this neighbor classifier, and the parameters that has to be passed to this object, this estimator, is saved in KNN underscore hypermeters, that is params and param underscore distribution. CV is equals to 3. CV equals to CV3. CV means cross validation. So basically our whole data, it will be divided into 3 parts. Whole training data, x underscore train, it will be divided into 3 parts, and 2 parts will be used to train it, and the third part will be used for validation. And that will be repeated. All those third parts will be interchangeably used as training and testing. Here I forgot to import the for library for randomized search CV. So first I'll do that. Importing the library for randomized search CV. Okay. Let's make it into form of comment. From sklearn.model selection, import randomized search CV. Randomized search CV. And further, for the evaluation of our model, I will be importing the metrics. Metrics are generally the classification score, confusion matrix. These will give me an idea of all the metrics, and accuracy. So from sklearn.metrics, import classification score report, confusion matrix, and accuracy score. Further, we'll make a data frame in which we'll score the accuracy score of all the models that we are seeing today. So result equals to pd.dataframe, and it will be having two columns. One will be the name of the model, and the other will be accuracy score of that model. Okay. Now I'll fit my x underscore train and y underscore train in this grid search. KNN underscore grid search dot fit x underscore train and y underscore train, and KNN underscore grid search dot best params. This will display the best parameters after the training, after it has fitted. The what parameters give me the best result, that will be displayed by this line. Okay, let's execute it. K nearest neighbor K neighbor classifier is not defined. I seem to have made some mistakes. Let me check it. Spelling is okay. Okay, K neighbors. Okay, I found the first mistake. X underscore tray. Okay, train, spelling mistake. Next, there seems to be some problem here. Let me check it. Hmm, for input variable with found input variables with inconsistent numbers. Okay, but x underscore train, y underscore train, that is okay. There is no issue here. Hmm, and found input variables with inconsistent number of samples. Okay, which means x is having 32843 and y is having, so this is wrong. This should not happen. No? I have made some mistake earlier in the code, it seems. Let me check it. X train, test, Y train, Y test. Okay, it is okay here. No issues here. Okay. So let me check it whether I'm trying to identify where the problem has started. See, X and Y here, they are having the same shape. So the problem has started after this step only. Let me see. So, okay, I found the mistake. Sorry, here, not, it will be, sorry, no, this is wrong. See, x equals to train. X train I have fitted and x test I had to scale because see why feature variable is not scaled. We do not scale the feature, sorry, and this target feature. The target feature we don't do the scaling. I will try to run this all. Okay, see, I have made that mistake there. Just a minute, I'll change it. So it will be x underscore test actually. This is the mistake that I was making. I failed to realize it in the beginning, but it's okay. Okay, so now it's done. Now I think it will execute. Well, it seems that I did make a mistake, but you got to see how I did the troubleshooting here. First, I search means tried to search where the problem was, at which line code the problem must have started. While making these long programs, generally these kind of silly mistakes we tend to do. Okay, let's move ahead with our program. Now I have executed it. See, while this execution is going on, this will take some time. So I will utilize that time to these warnings you can ignore, no issues with the warnings. So while this program is executing, while that model is being trained by the randomized set CV, I will write the code for analyzing the model, for evaluating the model. Just a minute. Okay, let me hide it. It's not hiding. No problem, no issues. Yeah. So model will take some time to train. While it is at it, we'll make setup. We'll write some code to evaluate them. Okay. Predict the test results. See, I'm writing this code. I will execute it only after that fitting is done. Otherwise, it will anyway not execute it. It will execute it only after the previous line of code has been executed. So KNN underscore y underscore predict is equals to what was that? KNN underscore grid search dot predict x underscore test comma simple x underscore test. So this will give me the predicted values, means x underscore test is given as input variable, and what the model has predicted that will be stored in knn underscore y underscore predict. And this knn underscore y underscore predict, this is the predicted values. This I will compare with the actual y underscore test values, which is the actual values, and then we will see whether means what is the difference, means how many times the model got it right, how many times it got wrong. That way I will get the accuracy score. So model evaluation, confusion matrix, classification report, and accuracy score. Print the confusion matrix. Let me check whether my model is still working. It seems. Yeah, my model is still training. I'll make use of copy and paste. I'll copy the whole line for classification report. Just change the values. See, these lines of code that I'm writing for the model evaluation. Next, for the next models, I'll be reusing them. I will copy paste the whole lines and I will just change the name of the model. That way, it will save me time and it will also help me in means see, while writing there is a possibility that I might make some mistake. So copy pasting it will reduce the chances of me making a mistake. KNN accuracy equals to accuracy underscore score. Again, I have to pass these two lines, y test and y predicted. And I will store this accuracy score in the data frame that we had created in the beginning. Result.loc0 equals to KNN classifier and KNN accuracy. Okay. Okay, I think so. Our model is still training. We'll have to wait. So as I mentioned before, the above code will be reused by us in other models also. by using the copy paste and modifying the name of the model. Okay, my model has been trained. Training is completed. See, these are the best parameters that the model has selected. The randomized search CV. Okay, now let's execute our evaluation lines. It seems to be taking some time. Okay, got it. So here I have precision recall F1 score. Right now what I'm concerned with is accuracy. So this model is giving me an accuracy of 71%. Okay, KNN classifier has given me a 71% accuracy. Okay, on with the next model. Next model that I want to train is decision tree. So from sklearn.tree import decision tree classifier and dt equals to dt underscore clf, which is the object, equal to decision tree classifier. Now defining the hyperparameters for the decision tree. See these hyperparameters, which means the parameters for the decision tree classifier. This you can check on the sklearn website. You can directly put the name of the classifier. It will give you an idea of it. Right now, for the demonstration purpose, I'll be doing it a bit fast. We will see the explanation of these models in some other video. So criteria splitter, minimum samples leaf equal to okay, let's go on. So these are the hyperparameters: minimum sample leaf, minimum sample split, maximum depth, and maximum feature. Next step is storing these hyperparameters into form of a dictionary. Putting hyperparameters in form of dictionary. dt underscore hyperparameters equals to dictionary criteria equals to criteria splitter equals to splitter minimum sample sleeve equals to minimum sample sleeve minimum sample split. Next I have maximum depth and maximum features. Now I have to make the randomized search CV object for the decision tree. dt.grid search. Randomized search CV estimator will be, just let me check one thing. Okay. Okay. So estimator is dt underscore CLF. Sorry, CLF. Params underscore distributions equals to dt underscore hyperparameters. CV is 3 and verbose equals to 10. Sorry, CV is 3, not 10. Okay. And now I have to fit that model on the X train and Y train. Basically fitting the training data on the grid search. There seems to be some error. Positional argument follows keyword argument. Okay. I forgot to put here. I forgot to put some values here. Max underscore features equals to max underscore features. Okay, what's now? Key learn. Sklearn. Okay. Next is d underscore CLF. Line number 25. Okay. Estimator equals to dt. It will be dt, not d. Okay. Model has started to train. And see, it got trained quite quickly. KNN, K neighbor class, K nearest neighbor, it had taken a lot of time to train my model. But this was quite quick. It hardly took any time. Let me display the best parameters. Okay, these are the best parameters that were selected by the model randomized search CV. Now I'll go for the evaluation. As I had mentioned before, I'll be reusing this code. I just have to do copy paste. And just change the variables. Instead of KNN, this time I am using DT decision tree. Just replace the KNN by DT and it will be fine. DT underscore accuracy, DT decision tree classifier, DT underscore accuracy, DT underscore grid search. Okay, I think I have covered most of them. Yeah, this also I have to change. Okay, let me see. I'll try print the result. Let me see how. Okay. It's not getting. It's not showing that good. It's better if I display it normally on. Okay. So see, the accuracy has increased. It is giving me better accuracy than KNN. In KNN, I was getting 71%. Here I am getting 75%. That's a really good improvement over the previous model. Okay, let's try the third model, that is random forest classifier. From sklearn.ensemble import random forest classifier. Rf underscore clf equals to random forest classifier. Again, similar to the previous steps, I have to define the hyperparameters just I did in the previous models. Criteria, Gini and entropy, maximum depth, minimum sample sleeve, okay, minimum samples split to 4 and 5. Let me just do 5 and 10. Maximum features, max underscore features, and underscore max underscore features equals to auto and square root sqrt. Bootstrap equals to true and false. First it will be testing on true also, and the model will be tested for false also. Best of the true will be selected by randomized search CV. So putting it in form of dictionary. Same as in the previous steps. Criteria equals to criteria, maximum depth equal to maximum depth, minimum sample sleeve equals to minimum sample sleeve, minimum sample split is equals to maximum features bootstrap. RF, now defining the grid search. rf underscore grid search equal to randomized search cv estimator is equals to random forest classifier. The object rf underscore clf that we have created for random forest classifier. The hyperparameters will be passed into param underscore distributions. I want cv to be 3, cv equals to 3, and verbose equal to 10. Now fit it on the grid search. Fit the training model data on the grid search. So rf underscore grid search dot fix x underscore train y underscore train. Best parameters best underscore params. Okay, let's execute it. First error is again I did the same mistake, sorry. Minimum samples, maximum features. Similar mistake I had done when I was making the previous model also. Strap equals to bootstrap. Okay. Okay, it has started the training. And while it is training, I will use that time to make the evaluation code, to write the model evaluation code. I just have to do the copy paste. DTRF and replace by RF. Now in the result, I will store it at the second location. Random forest classifier and RF underscore accuracy. Okay, so it's done. Let me check it. Okay, the model training is also complete. Now metric evaluation. See, my accuracy has kind of decreased in random forest classifier. Well, it's okay, no issues. So it seems that up till now decision tree classifier is a better model for me. So the next one, that next model we will be doing is logistic regression. Let's just for demonstration purpose, we will get an idea. These see implementing these models, no? This will give us an idea about. This will clear our concepts, and these are very good for practice. So logistic regression, it will be imported from the linear model library of sklearn. So from sklearn.linear model, import logistic regression. Make the object for logistic regression by the name of LR. LR equal to logistic regression plus function sign. Now make the hyperparameters. Here hyperparameters will be writing it. Just I have I have made the workout and I have written it. You just observe that how it is being implemented. Further detail we'll go into the we will go into the further details later for when we'll be learning about logistic regression exclusively. So there is a thing called penalty L1, L2. Penalty L1, L2 is for regularization, means lasso and range things. So penalty can be L1, L2, elastic net or none. That is the first parameter that I would like to tune. Other one is C. C. Let's keep it. This can be this C has to be some integer and it has to be some positive integer. So C np.log space minus 4 to 4 and 50. Solver equal to LBFGS and Newton CG. See, all these values we can refer the sklearn library, means the data sheet is there. If you put sklearn.logistic regression on Google, you will get it. So you'll get all the parameters and what are the possible values that can be used for it, and that we can use it here. For now, just for the implementation purpose, you just observe it that how it is being implemented for demonstration. Okay, so the hyperparameters values are ready. Put it in the form of a dictionary. Penalty equals to penalty. C equals to C. Solver equals to solver. Maximum iteration equals to maximum iteration. Okay, my hyperparameter dictionary is ready. Next, make the object for grid search. LR underscore grid search equal to randomized search CV. Estimator will be the logistic regression. Parameter distribution will be LR underscore hyperparameters. Further, cross validation I am using 3 for all the models, and verbose is for displaying the number of steps. I am using it as 10 in this problem. You can use any number. So estimator is LR. Simple. LR is the logistic regression object. Param underscore distributions equals to LR underscore hyperparameters. CV equal to 3, verbose equals to 10. Now that my grid search is ready, I have to fit my training data on this grid search. Okay. This line of code for displaying the best parameters. Okay. It is running, it is training, and while it is training, I will prepare the evaluation code. Copy and paste, just change the values from RF to LR. Rest all the objects, rest of the code, rest of the code will remain the same. Further appending the value of this line will append basically enter means one more entry will be made for logistic regression accuracy result.loc3. I don't think it will be loc3, it should be loc4. Just a minute, I'll change it. Okay, it seems that my accuracy score has decreased drastically in logistic regression. Well, I'm not sure the exact reason for such a huge decrease, but it's okay. Well, whatever my model has created. So more tuning further it can be done, but for now, since it's only for demonstration purpose, I'll not be going too much deep in this. But okay, so one of the options, this logistic regression, for now it's giving me 25% accuracy. Not a very good performance. Actually, it's a very poor performance. Just let me confirm if I have made any mistake. Actually, I'm not sure I've done anything wrong here. Let me see. No, everything seems to be okay. Okay then, I'm moving on with the next model, which is the XGBoost. XGBoost classifier. From XGBoost, import XGBoost classifier. XGB classifier. Now make an object for it. Time to define the hyperparameters. Maximum depth. Learning rate. N underscore estimators, number of estimators. The alpha values. Similarly, I have to make for alpha, lambda, and gamma. Lambda and gamma. Booster, GB tree, GB linear. Again, similar to the previous models, putting all the hyperparameters in a dictionary. Okay, so hyperparameter dictionary is ready. Next, to make the randomized search object for grid search, basically. Estimator is XGB underscore CLF. Param underscore distribution will be XGB underscore hyperparameters. Cross validation is 3 and verbose equals to 10. Now fitting the training data on this grid search option object. Sorry. Grid XGB underscore grid search dot best underscore params. Okay, executing this, we'll be executing this model now. There seems to be some mistake. Randomized search. Distributions also spelling is wrong. Okay. Cannot clone the object. Not object, I'm not able to clone. Okay, it's executing, it's working now. And while it's working, as before, I'll just evaluation parameter, evaluation code, line code, I'll just copy paste. Just replacing the LR by XGB. Okay, my model is still running. I will have to wait for it to complete its training. Okay, so model training is completed. Here it is. Let me check the. Okay, I seem to have made a mistake. I forgot to change the index in result and result.loc. So actually, I changed it, but I changed it after executing it. I got a bit late, so I'll just correct it here. First, I'll execute this line of code. Executing this whole code will put again. It will put at the third index. Index 3, it will put logistic regression. Further, when I execute this code, it will put XGBoost in that. See, I got it. So if you see here, XGBoost has given me the highest accuracy of 78%. So for this is the comparison. You have observed that we have successfully implemented 4 models for classification, and we were able to compare the accuracy of all of them. Well, we'll conclude it here. We'll conclude this program here. Thank you.